To help my students with their maths revision, I'll start my first session for this year with three interesting problems randomly taken from year 9 and 10 exercise papers, which I hope you enjoyed. The first one is question 19 from Intermediate Mathematical Challenge from 2009. Driving to Birmingham Airport, Mary cruised at 55 miles per hour for the first 2 hours and then flew along at 70 miles per hour for the remainder of the journey. Her average speed for the entire journey was 60 miles per hour. How long did Mary's journey to Birmingham Airport take? Let us start with a graphical representation of the information given. On a straight line, we'll mark the beginning and the end of the journey, as well as the speed and time in two sets. For the remainder of the journey, we'll assign a variable y whose value we'll need to find to solve the problem. When we talk about speed and time, we always remember the popular formula in which their product is the distance. In this time, we're going to rearrange this distance times speed formula as follows. In the numerator, we represent the distance as the sum of the two smaller distances, and in the denominator, the time as the sum of the two part times. The speed for the entire journey is already given as an average speed. Further, by simplifying the numerator and multiplying both sides by 2 plus y, we're going to simplify our equation as follows. Finally, we can see easy the value of y is 1. What is the value for the remainder of the journey? The last step is following. The answer is 3 hours. The next task is taken from Edexcel GCSE papers mock set 2 from the spring 2017 session, question 9 from paper 1H. 1 liter of a liquid P has a mass of P grams. 1 liter of liquid Q has a mass of Q grams. A liquid R is made by mixing a volume of liquid P with liquid Q in the ratio 3:7. Find an expression in terms of P and Q for the mass of 50 liters of liquid R. Let's again graphically represent the information given. There are two liquids of equal volume 1 liter with different masses, P grams and Q grams respectively. One note: for any two substances, including liquids of equal volume, it is always true that they differ in their masses as well. There is another third liquid, R, which is a mixture of the volume of the liquids P and Q in proportion in the ratio 3:7, which we can restate in this way. For every unit of liquid R, it's always true that it contains 3/10 of mass P and 7/10 of mass Q. Now, graphically represented, this information looks like this. 1 liter of liquid R contains in terms of mass 3/10 P plus 7/10 of Q grams. Now, let us represent the amount of liquid in terms of liters and mass in terms of grams. For 1 liter of liquid R, the mass is, as we have seen, 3/10 P plus 7/10 Q. for another amount of the same liquid R, let's say 50 liters, as we were asked to look at, we need to find the multiplier. Uh, in this case, this is 50 from the left side, which to use on the right side as well by multiplying the mass of 1 liter in terms of P and Q. We find an expression of 50P plus 35Q. The expression for the mass in grams in 50 liters. And we can come to one final statement. To work out the mass in terms of P and Q for any amount of R, multiply the two sides of the ratio 3/10 to 7/10 by this amount. Question 3 is taken from the Intermediate Mathematics Challenge 2002, question B3. I walk to the bike shop at 3 miles per hour and cycle back along the same route at 12 miles per hour. What is my average speed in miles per hour for the time I'm actually traveling on the route? Let us first start by graphically representing the information given. On a straight line, I'll mark the beginning and end of my journey as well as my walking speed in one direction and cycling speed in the opposite direction. In this context, it's quite natural to use the well-known distance times speed formula. This time, however, adapted to calculate the average value of the speed traveled as follows. In the numerator, the total of distances traveled, and in the denominator, the total of part times. The diagram shows the distance in both directions is one and the same, but can be expressed differently by using this formula. In this line, we can see the walking distance expressed as a product of the walking speed and variable x for the entire walking time. The cycling distance as the product of cycling speed and variable y for the entire cycling time. Further, in the general formula, we're going to substitute the two distances as follow: 3x plus 12y in the numerator, and the total of time as the total of the walking and cycling time. Further, in the same formula, I'm going to substitute one of the terms with the other one, as we know that they are equal. I have chosen to substitute the walking distance with the cycling distance. In the end, I simplified further the numerator to get 24y. In the denominator, I'm going to substitute x time with 4y, which I get by cancelling these two expressions by 3. And further, I simplified the denominator to come to get 5y. The next step, by cancelling y and dividing 24 by 5, I get 4.8 miles per hour. What is the answer?